So we start with the next session, integrating eBPF superpowers into your observability tooling. And presented will be this talk from Mauricio and Chris, and I say a warm welcome for both of you.
Second. The thing's on. Hi, I'll start with introductions. My name is Chris. I work at Microsoft. I'm a technical PM at Microsoft. This is my colleague Mauricio. He is a software engineer at Microsoft. Yeah, and this talk is about integrating eBPF superpowers into your observability tooling, and we'll get started now. So this was the introduction. The little part at the bottom, we joined Microsoft both in 2021 as a part of the acquisition of Kinfolk, where we both worked, and we worked on this type of technology since then and have continued that in Microsoft. The agenda for this talk is to look at eBPF a little bit and the scope of observability. We're going to go then into an intro to Inspektor Gadget, which is basically something that makes eBPF observability super simple, and we'll show you demos for that. And this, I'm going to be running through the slide portions of this because this talk should really focus on the demos. So we have one demo is going to be about triggering alerts, showing you how to use eBPF programs and the Inspektor Gadget tooling to basically do alert generation. We're going to then look at how you can get these basically off-the-shelf BPF tools. We call them gadgets inside of the Inspektor Gadget project, and we're going to talk about those a little bit. Then we're going to look at network latency and show how you can basically feed the data that you're collecting from these gadgets or eBPF programs into Grafana. And then we're going to look at a little bit at Inspektor Gadget as a framework for observability. And then the last demo is going to be debugging a crashing app. How many people have used strace? Probably some of you. How many have used it across the cluster? Probably not. We'll show you how you can do that on an on-demand way. Unfortunately, we didn't finish the integration with Headlamp because we're working on various things there. But tomorrow there's a talk on Headlamp, and you can kind of get the idea about what that is if you go to that talk. And then we'll do a conclusion. So eBPF and its superpowers. Why use eBPF for observability? Who has used eBPF here? Have you used it directly, or have you used it through a tool? Almost everybody has used it through a tool, but a couple people have used it directly. But what we think you should be able to do is basically take something, an eBPF program off the shelf, and just say, somebody wrote that, similar to a container, and I want to use that in the way I want to use it inside of my system. And that's what we'll show you with Inspektor Gadget. But eBPF, it basically runs in the context of Linux, the Linux kernel context, right? Usually. There's also some user space stuff you can do. But the idea is that there's some things that are much easier to do in the Linux kernel, some things that you can only do in the Linux kernel. And basically you tap into the kernel without modifying the kernel. And this is very different from something like Linux kernel modules, which basically you're creating a kernel module, you're basically sharing the kernel space, and eBPF programs, though, are safe. That means they cannot crash the kernel because they don't have that shared memory. It runs in a sandbox. This is very different from Linux kernel modules. They're very high performance and very efficient. They're basically event-driven. When you load an eBPF program into the kernel, you are basically, it's sitting there waiting. When the event happens, it executes, and then it puts some data into the map, and then that can be pulled out from the user space side. And very important is eBPF is general purpose. You might know it for networking. You might know it for some security stuff, but it can use for a lot of things. And one of the things that's happening inside the kernel is figuring out more places to use it. And so challenges to using eBPF. If you're not a kernel developer, it's probably going to be hard to create BPF, and that's why I was asking you, do you use it directly? Because there's a very high bar to doing that, and we want to lower that. The data collected is only in the context of the kernel. This means you're getting information about maybe a mount point, the mount namespace, sorry, a C group, things like this. You're not getting information about your pod or your container. So you want to have some kind of mapping there. And then managing and loading the eBPF programs across your cluster, that's a challenge. So if you're using eBPF directly, there's a lot of steps you need to do. Write the eBPF program if you don't have one, compile it to ELF, make sure it works across kernels and architectures, so it needs to be portable. Deploy across all your nodes and manage that. Load into the kernel. You can basically do a syscall or you can use a library. Gather the data from eBPF maps from user space. You can do that directly or you can do it with a library. For example, if you're doing Go, if you're doing it in Go, you can use the Cilium library for that. You need to associate that data with high-level resources like Kubernetes containers. You need to then perform any possible post-processing because there's some things, because it's safe, you can't do inside of eBPF. For example, string processing, because it's sometimes unbounded, is difficult. And then you need to format, sort, prepare that data for export to your observability service, and then you need to send it. And so Inspektor Gadget kind of takes care of all of these, and that's the whole point of it. The description we have on the GitHub page is Inspektor Gadget is a set of tools and framework for data collection and system inspection on Kubernetes clusters and Linux hosts using eBPF. And so we're going to cover some of the tools. We're going to look at a little bit of the framework, and then we're going to focus mainly on data collection here. Interesting is that Inspektor Gadget can not only be used for observability tooling, like feeding it into something, doing metrics gathering and things like that. It can also be used on the command line directly. You can actually even interface with the same BPF program in both ways. You can be sending it to the metric server and log in and see what it's actually doing on the command line. And we're going to be focusing on Kubernetes clusters, but it also it also supports running it straight on your Linux host. So this means that sometimes if you really want to, the Kubernetes cluster support relies on the Kubernetes API. If you actually want to get below that, you can actually just install it directly on the host. So before we get to our first demo, I want to run through these key features so you're kind of understanding what's going on, what's the point of this. So Inspektor Gadget builds and packages eBPF programs into OCI images called gadgets. It distributes and manages the eBPF programs across your cluster. Now, if you look at these first 2 points, people have said that basically it looks like a package manager and an orchestrator for BPF programs. And it does do that. It also does other things. It collects and exports the data to observability tools with a simple command. So you can use a command line, or you can use a declarative configuration, which I think we added in the last release. This means you can check that into GitHub and just have that run again the same way. It has security mechanisms. Because these are OCI images, you can pull them down from different places. You want to be able to restrict or lock that down in some cases, in a lot of cases actually. It does automatic enrichment. Now, enrichment is that term for mapping that low-level stuff to the high-level resources like Kubernetes and containers. It also supports WebAssembly modules for doing post-processing when you can't do everything inside of the BPF program. And then you can use it in any WASM-supported language. It supports many modes of operation. You can use it from the CLI. You can have a client-server relationship. You can actually start in daemon mode and then talk to it with a client. You can control it by the API, a gRPC API. And then it's also embeddable via Golang library. So you can actually take Inspektor Gadget, have that, use the library, and you have all the functionality, but it's just a library in your application, as long as you're using Go. So the first one will be about alerting when, for example, a shell is opened. So Mauricio.
Thank you, Chris. So the first demo I'm going to show you is how we can get alerts when a specific process is executed on the system. In this case, when a shell is executed on the cluster. And yeah, in order to do that, the first thing that I need to do is to deploy Inspektor Gadget to the cluster. What I'm saying here is enable Inspektor Gadget to export metrics to OpenTelemetry. We are using the OpenTelemetry library to export metrics to Prometheus as well. And then this is the address that we want to use for those metrics. So this is deploying Inspektor Gadget on the cluster. And before this, I already have Prometheus deploy on the cluster. I'm not going through all the details of this Prometheus deployment that I have here. The only thing I want to mention is that we are using the service discovery feature of Prometheus. What it means is that we have configured we have annotations in the Inspektor Gadget pods with some label that say, hey, Prometheus, please scrap the metrics from these pods. So there we have annotations with the name of the metrics, the path, the port, and so on. Okay, so I'm going to deploy this gadget here. So this is how we can deploy a gadget to a Kubernetes cluster. This is very similar to how you deploy a pod in Kubernetes. So we have a YAML manifest. In this case, it's an instant spec manifest. We have the image that we want to run. In this case, we are using the strace-like gadget. So this is a gadget that provides information of what are the processes that are being executed in the cluster. We give a name of that gadget instance. And then in this part of the configuration, we put all the parameters that we want for this specific gadget. So for instance, here we are enabling this gadget to work on all namespaces. So we want to monitor all namespaces on the cluster. We could be providing a list of specific namespaces that we want to provide, that we want to monitor if we want to do that. In this line, we are configuring the filtering. So we are only interested on shell. So we are filtering only events which process is named bash. For sure, if we want to monitor other shells, we should be including the names of other shells there as well, but this just, for this demonstration, we only care about bash. Then we configure everything that is related to the metrics. So we give a name of the metrics that we want to expose. And by using this annotation approach, we configure those metrics. So here we say to the gadget, hey, expose the metrics. Here we say, let's count those metrics on user space. So for this specific gadget, we don't do the counting in eBPF, but we do the aggregation and the counting in user space. So this is a way to enable metrics for gadgets that don't have that support directly implemented on eBPF. Finally, we also configure what is the cardinality of the metrics that we want to collect. So in this case, we will have labels for the Kubernetes namespace, for the pod name, and for the container name. So this is how I can deploy that to the cluster, very similar to how you deploy something in Kubernetes. So I pass this file here, and I'm using this detach flag to say run that on the background. And yeah. For sure, this is a demonstration. I'm forgetting about the right command. There we go. So if we do a kubectl gadget list, we can see that our gadget is there on the cluster running. And the nice thing, as Chris was mentioning before, is that we can attach to those gadgets to see what they are doing. So yeah, let me get the name of this right process. So this is a way how we can debug what the gadget is doing. So in case this is not exporting the right metrics, we can attach to that and understand what is going on. So I will run a pod on my, oh, it's already there. Great. OK, I can change the name. That will be faster. So I'm running a pod on this. And as you can see there, we got an event saying, hey, this process was executed on the pod. So we are only monitoring this process. And what is happening here is that this gadget is providing that information on the terminal, but at the same time, this is exporting that to Prometheus. So if I go to the Prometheus instance that I have running on this cluster, I can look for the metrics. So the metrics is shell execution total. If I look at that, you can see that for my pod Ubuntu 3, there had been three executions of the bash command. And once we have the metrics available on Prometheus, we can configure alerts on top of that. So I have this alert that will say, that will fire once that counter is more than 0. So it means when a process was executed. It will take a little bit of time for that metric to fire. I will be back to that in a second.
Yeah, so while we're waiting on that, let's take a look at actually what these tools are, or these gadgets are. Basically, these are eBPF programs, and they're packaged in OCI container or images, right? And you can, this makes it so we can use very similar tools to what the container infrastructure stuff uses. So we build and maintain many gadgets. We have almost 30 now, so you're bound to find something useful. But if you don't find something, then you can reach out to us, and we'll, we can either offer our help, or we can help you do it yourself. We're happy to take PRs for things like that. But the cool thing is, because this is OCI image, you don't have to actually interface with us. You can have your own in your own repository, and you can just make use of the framework. But gadgets are more than eBPF programs. So you have one or more programs in a gadget. You also have a WASM module, which allows to do this post-processing. And then we have the metadata YAML. You saw in the last demo, there was a field where we could say, oh yeah, only fire this on bash. So this actually is doing on the bash executable. This is something that the metadata will define. So the metadata basically defines the capabilities of that gadget. There are some gadgets that have a stream of events, like the trace gadgets. This one that we looked at was trace exec. There are others that do an interval, kind of a top thing. There are others that just give a snapshot. And then we have a few other types. So that's defined in the metadata, along with some parameters that you can pass, for example, the bash one. And then lastly, we have this BTF gen. This is for portability, so this will run on many architectures and many different kind of kernels. So if you're looking for those gadgets I was talking about, you can go to Artifact Hub. We have a bunch of them. Here I have it filtered for the official ones. There are some unofficial ones, and if you create one, you can share it there, and then other people can make use of it. So that's the idea, and it's very similar to how the container world works. So we're going to take a look at the result of that last one, and then do the network latency demo using Grafana.
Yeah, sure. Thank you, Chris. So this second demonstration is about how to get network latency by using some of the gadgets. But before that, you can see the previous alert is now firing, and we got the message here that says truth shells have been secured. Okay, so yeah, in order to provide or to collect the network latency on the cluster, we can use this gadget. This is something that we call profile TCP runtime time. So it gives you the latency of the TCP connections on the cluster. So I'm going to deploy this in a different way this time. So I have a script here. And instead of using a manifest file, I will just run that from the CLI. This is just to show you another way to run a gadget. So the syntax is very similar to the previous one that we have on the manifest. So in this case, we say, what is the image that we want to run? We also give a name to that one. The attach is the same meaning, not to remain the terminal attached to that process. And the annotation is very similar. So we are enabling the collation of metrics there, and we are giving a name to the metrics that we want to export. So yeah, the gadget has been deployed. Again, if I do list, you can see that we have that gadget already running on the system. And as before, we can also attach to that one. So yeah, in this specific case, this gadget is able to output a histogram to the terminal. It could be useful in a case you don't have Prometheus or Grafana available on your cluster. So by only using the terminal output, you could also be able to debug some of the issues that you have on your cluster. Right. So in this time, I have configured Grafana to talk to Prometheus, Prometheus to talk to Grafana. So yeah, let me show you the dashboard that I created for this one. So this is a heat map. It's telling us what the latency for the connections is. And yeah, actually this is an empty cluster, so I don't have a lot of connections there, but you can see that there are some packets and the latency that they have. So I'm going to deploy a small application on my cluster that is going to create some TCP traffic. So this is just a client and a server. The client will try to download some files from the server. So hopefully we'll be able to see some more traffic on our dashboard. So let's see if that's running. Yeah, that's running. So if I go to this one, you can see that here we have a lot of packets there, and almost, the latency for almost all the connections in my cluster is about microseconds. So yeah, this is because we are running on the same machine or whatever. But what about if I introduce some latency to those connections? So I'm going to use TC with a QDisk in order to introduce a 10 milliseconds latency for all the connections coming from the client pod, and hopefully we'll be able to see a difference in the heat map that I was showing before. So I'm going to refresh this as much as possible. So as you can see, we are starting to get some numbers on this one. So as you can see, we are getting more and more packets on this one. So it means that the latency of the connections on our cluster is changing, and we are having a higher latency. So yeah, actually, I don't have the time to wait until all of this is done, but in the end, we will see that most of the latency is around the 1 millisecond there. But yeah, what about if we want to debug why this latency is happening? So what is the reason why our network packets are taking too long to arrive? So in order to do that, we could use another gadget. So we have this straight TCP drop gadget that is going to tell you when TCP packets are being dropped by the kernel and why those packets are being dropped. So let's run the gadget there. And as you can see, we have a lot of packets that are being dropped for the core client pod. And this is the reason. So this is why the kernel is dropping those packets. And this reason corresponds to the TC QDisk that we configure on that pod. OK, Chris?
All right, so we just demonstrated two more tools, the round trip timing and of network packages, and then also the drop packages. So, but those, so basically these gadgets, they're can be used in many different ways, and we just saw that. We just saw some of it going to metrics, some of it you can use it on the command line, and you can interface with these by API or even by consuming it as a library, right? So the idea is that when you create a gadget, it can be used in many different ways. And so this adds not only value to the framework, but also if somebody's going to create a BPF program, if you do it as a gadget, you can use that in a lot of different ways, and you don't have to do all the boilerplate stuff for the specific use case. You can just do a couple configuration or parameters. So the metadata, as I've expressed before, defines to the framework the capabilities of the gadgets. So if you try to, for example, send metrics to a from a gadget that doesn't support that, then it'll error out, right? So it allows really the developer to deal with the business logic. I put business logic because I never knew what that was. But you know, it's the stuff that you don't want to have to deal with. It's the stuff that adds value to what you're doing. You don't want to have to do this boilerplate. And for here, you can get rid of the boilerplate if you find an off-the-shelf gadget. But you can also get rid of the boilerplate by just, you know, if you create your own gadget, then using the framework and not having to do all of that. And the framework is designed to be extended. For example, we support now Kubernetes and container runtimes for getting that information. We want to extend that to, for example, VMs or systemd, so to understand what units it belongs to. But we don't necessarily want to have to bake that in. So we want to have this idea of extending the enrichment or other parts of the framework. So the next one is about debugging a crash app, and a crashing app. And what I will say about this one, this is the one that we didn't quite finish, but we'll talk through basically the use case at the end if we have time. Right.
Yeah, sure. So the idea here is there are times when you have an application that is crashing on the cluster and you have no idea what is going on. So the application is not providing any login, and you cannot use any other tools, maybe because you are using a distroless image, so you don't have any other tools available on the container to debug what is going on. So we have a gadget that is called traceloop. We can think about that gadget as a flight recorder that records all the activity performed by the different pods or containers on the system. And when there is a crash, we can see what happened to that container. So it's quite similar to the idea of a flight recorder on an airplane. So when there is a crash, we are able to understand what happened, what was the data of the different sensors, and so on. So the first thing that I'm going to do is to start traceloop on my system. And then I'm going to deploy my application is a very simple. It's a very simple pod in Kubernetes, so this is using a special image that I created for this demonstration. Okay, so if I check, you see there is an error. So this is not on ready state, and this is being restarted. So we could get the logs from that. This is called my app, but as you can see, there is no any information there. So maybe we can use trace loop for that. So I can do the list command. So this is going to print the traces for all containers running on the system. So as you can see here, I have 3 different traces for my app container. So it means that it has already been restarted 3 times by Kubernetes. So I have different traces there. So I can use the show command, trace loop show, and let's pick the last one of that. So by doing this, we are checking all the syscall activity of the container. Let's remember that this container is already gone. So this is like looking into the past of the container. So we see what is the command that we're executing those system calls. We have the name of the system calls, and then we have all the information about the parameters and the return value of those system calls. So maybe we can just jump right away to the last syscall that was executed by this container. So we can see that it was trying to open a file. This is the name of non-existing file, and there was a -1, a return call. So this gives us some information. This container is trying to open a file, and after that it's crashing. So probably we could investigate why this file is not present on the system, or why the container is crashing for that. So I can show you very quickly the implementation of this program. As you can see, I'm opening a file there and not performing any checks on the return value of that, so my application is crashing around here. Okay, Chris.
Yeah, so the idea there, and what we actually wanted which we actually had a POC like a few years ago actually, that we wanted to actually implement for this and actually get as a plugin for Headlamp. By the way, there's a talk tomorrow about Headlamp, which you can get a better understanding of that. But the idea is that if you have an app crashing in your system, you can push a button, activate this, and then the next time it crashes, you can get a notification and says, oh, you can take a look at this, because this is going to run across your cluster. It can, it might be only certain instances of that app that crashes, and this will be able to find that. So across the cluster. And this is very low overhead, nothing like strace. So to wrap it up, if you want to use eBPF for observability, you should really take a look at Inspektor Gadget. And we're also very open to conversations and trying to expand use cases if we haven't covered something that you might be interested in. The status, all major planned features are now merged. We've been working on this for like 2 years to get it this way, so we're very happy about that. We're working on 1.0, likely mid next year. We are eager for feedback to attain that. You might want to take a photo of this, but I can also show it to you later. This is all the things that we're doing here at over the next week. So I'll leave that on a second. Okay. And then, yeah, we have GitHub, we have a web, and then I put these links in the README in a PR for the project README, so you can find them there. And that's the end of this talk, but we hope we can talk to you about using Inspektor Gadget, and look forward to your feedback. We have only a little bit of time for questions, I think, though.
I think we have time for questions, so. Any questions? I saw there. Okay, 2 questions there. Okay, let's.
Yeah, you said, yeah, thanks for the talk. You said at the end that this has a low overhead. Any ballpark number on how low is it?
The last time we did testing on it, it was so low that we were like, that's like, it was like less, it was compared to strace, it was hardly noticeable. So what this does, it basically puts this into these traces into a ring buffer, and they're just sitting there. When it crashes, you saw this list, right? They hang around, and so you can retrieve those later. And so that overhead of basically the BPF program putting stuff into that ring buffer is very, very little. But yes, there is some overhead. We do need to remeasure that. But yeah, sorry, I can't answer that.
A bit of a follow-up. So you were constantly running the tracing and
only when you
or
activate
when
it. The idea is that you we could have an automated system that says something is repeatedly crashing, identify it. And so the idea with this is that you don't run it all the time, right? You say, okay, this thing is crashing. I need to figure it out. And you basically activate it. And for that time, until you get a notification, you can just keep it running. That's the idea.
Could you please explain a little bit about the WASM integration? I didn't understand exactly how that works. And why did you do that?
Yeah, because
and when?
For example, we have
you give me the second to the last slide as well. I didn't get where you're going to be given the workshop.
Yeah, I'll give you a.
Yeah, that thing. Yeah, no, not.
Which one?
Okay. The second to the last. Yeah,
okay,
that
yeah.
one. Yeah, okay.
So the WASM is there because you can't do everything inside of BPF because there are security. It's a safe environment. Yeah. You can't just do unbounded looping. And when you're doing string processing, you might want to. You might not be able to do what you need to do inside of BPF. And so, for example, for our DNS trace tool, because that uses a lot of string processing, what we do, we then send all that information to user space. We use the WASM module to do the processing, so we can get the full, URL and the name resolution for that.
So it remains in the browser then with WASM.
What?
It's for the browser. It remains in the browser with WASM then, or what is? I didn't really understand.
Well, I mean, it's just a runtime, right? It doesn't. I mean,
right.
WebAssembly has a stupid name now because it's identified with the web, but it can run in the server. It's just a process environment, sandbox.
Okay. Okay. And when did you do that? When did you add that?
What is that?
When did you add that capability?
Probably about 3 months ago.
Okay. Good. Great.
Last question, okay? Quick one.
Yeah, thanks for the talk. So did I understand it correctly that all the information about the traces and crashes are stored in the node itself? So when the node is gone away, we lose all the data?
Yeah, so it's all in these ring buffers, right? And until you pull them out, like if you set up, for example, if Prometheus is fetching those, or I think it's like pull, right? And they'll just be there, and they'll be written over if it goes too much. So you need to have an interval that's like, that doesn't allow for that overriding. Generally, that's not a big of a problem because it can hold quite a bit of information. But yeah, it stays on the node. We don't have any like storage or anything. There's no storage. It's just in the kernel, and we try to get rid of it as soon as we can.
Gotcha. So the CLI just fetches all the ring buffers of all the nodes and prints out what's there at the moment.
Yeah.
Okay, gotcha.
Yeah, it's very, very efficient. And if you want to build on something on top of that, that's the whole point. This is a general purpose tool. Make it yours.
Okay, then thanks a lot for the talk. If you have any questions,
everybody.
I think you will be around and answer the questions. And yeah, stay tuned for the next talk from Eric about new kit in the sandbox.